Hello everyone. Today I want to discuss with you specific gravity in urine. So we want to see how we determine specific gravity in urine. And specific gravity, by definition, we're going to say that specific gravity, abbreviated as SG, is the mass, or it is got by dividing the mass. You can say mass or weight. Specific gravity is equal to weight of urine, then you divide by weight of equal volume of distilled water. So this is the formula we can use to determine the specific gravity in urine. So you're getting the mass or weight of urine, you compare it with weight of distilled water. And another name for specific gravity is density. So you can get the density of urine, you divide by the density of distilled water, you are able to get specific gravity. And this specific gravity we are talking about in this session is used to assess functioning, to assess the ability. Here we are assessing the ability, to assess the ability of the kidney, to concentrate or dilute urine. So we are measuring the function. Is the kidney able to dilute urine or able to concentrate urine? And this test of specific gravity is done in the sample or the specimen. We use early morning urine. Early morning urine is the one that is used. So the first urine you void when you wake up in the morning is the one we use. So it is preferred because we want to have a sample when you have taken 10 hours minus taking water or drinking water, so that we get the right value. So random specific gravity is of less value, so the sample of choice is early morning urine sample. And this early morning urine sample, after obtaining it from the patient, we use different methods. And we are going to tell you that the reference range of specific gravity is between 1.01 to 1.030. So that is the specific gravity reference. So if you find someone's range is below this one means it is more dilute. The kidney is diluting urine. And above this, it means the urine is concentrated. And we shall see different causes, whereby and when there is more dilute urine consistently, you're not taking much water and your urine is, the specific gravity is below this, we find we can suspect any tubular condition, that the kidney is failing to tubular failure of the kidney to reabsorb water. And if it is concentrated, we can suspect dehydration. Dehydration can be one of the factors we can suspect whenever you're consistently having greater than 1.030 specific gravity. And the methods we use in the lab to determine specific gravity, majorly we are using 4, whereby we can employ what we call urinometer, can use specific gravity bottle, specific gravity bottle. For this one, you can call it weighing method. Then we can also using reagent strip, which we call heuristic, and lastly we can use refractometer, but not commonly used. So these are the 4 methods that we can use to determine specific gravity. So in this session we are going to look at the first 3, is the one that we are going to drill on to see how they are used to determine specific gravity. And the first one we are going to begin with, urinometer. Urinometer method. And as we move on, we urge you to subscribe if you haven't subscribed. Like the video and share the comments. And you can recommend this video to others that we may continue to teach the group. So urinometer, which is the first method we can use to determine specific gravity, we use a urinometer bottle. And this one, among the requirements, we shall need measuring cylinder, we shall need a cylinder, we shall need a urine sample, which is early morning, we shall need a urinometer, and these are the major ones we shall need. After assembling these requirements, you're going to obtain at least, you are going to put at least 50 mils of urine in the cylinder, in the measuring cylinder. After putting up at least 50 mils of urine, you're going to, this one should be then the temperature. You adjust the temperature, adjust temperature according to the manufacturer. So the temperature is adjusted according, if the manufacturer is saying we do this test at 15 degrees centigrade, then we should do that. It's very important. So after adjusting the temperature, the manufacturer of the urinometer dictates which temperature you do the test. After that, so we have our measuring cylinder. If this is our measuring cylinder, and this measuring cylinder is having at least 50 mils of urine, this is urine, which we may want to measure the gravity. So you come and immerse. The next step, if this was number 1, number 2, step number 3 is to immerse. Immerse the urinometer in the urine at the center. So it should be immersed at the center without touching the edges. So you avoid for it to touch the edges of the measuring or the cylinder. And if the specific gravity, if the urinometer is new, you have to first adjust by measuring it in distilled water. And if I must, this is to note, I want you to note that if urinometer is new, if you are using a new urinometer, you have to adjust, you have to control it. We can use the word control or calibrate it by using distilled water. And the reading should be at 1.00, because we know the specific gravity of distilled water is 1.00. So since we know it, and in case you insert it in distilled water and you find it is not giving 000, instead it gives you 1.001, here you have to adjust by the answer you get, you have to subtract this. so that you rule out this error. So every time you get a new urinometer, you have to first calibrate it using distilled water because the specific gravity of distilled water is known. So after inserting our urinometer, if we come and insert, this is the urine we are measuring at least 50 mils, then you come and insert the urinometer inside, and this urinometer is calibrated. It's calibrated from 1.00 to 1.060, and each scale is 0.001. So that's how we urinometer. So when you insert it, it has to be in the middle and should be away from should not touch the bottom and should not touch the edges of the measuring cylinder. So after immersing it, it will sink depending on the concentration of the urine. If this urine of ours is dilute, if you have dilute urine, the urinometer will sink more. And if the urine is concentrated, the rate of sinking is low. It does not sink deeper. So after we have inserted it and it has stopped sinking, we come and we read the meniscus. We come and read the value of specific gravity at the meniscus. We said it has readings, so in case maybe it has stopped here, and this is maybe 1.020. So at the level of meniscus, where the urinometer has stopped being suspended in your urine, you come and read that meniscus at the level of the eye. The meniscus is read at the meniscus, then at the level of the eye. Then you read and record. Here, after reading, you record the specific gravity results. And because here at the meniscus is at 1.020, so we record 1.020 as our reading. Just remember, it is the ratio, so it has no units. It has no units. And I want you to master today that the specific gravity, why we compare with the distilled water, is that we already know its specific gravity, which is 1.00. So that's why we normally compare it with. So in summary, with the urinometer, you get at least 50 mils of urine, you put it in a measuring cylinder. Then if the urinometer is new, you first test it using distilled water, and in the case it does not sink, it does not give the meniscus at 1.00, you adjust, then you subtract that addition. Then afterwards you immerse the dry clean urinometer into the urine in the center, avoiding it to touch the edges. And this container we are using, it should be free from detergent. Another note is that the container should be free from detergent, because the detergent lowers surface tension. It lowers surface tension and it can give false high. So one of the sources of error is using a container with the detergent, which lowers the surface tension and can give false high specific gravity results. So the things to note which can lead to source of error is the failure to adjust if you are using a new urinometer, and also making the urinometer to touch at the edges or at the bottom, and another one using the container with detergent. That is one of the sources of error we can see. So that is the urinometer. The next method we can discuss with you in this session is specific. We can discuss with you the second one, which is reagent strip. Sometimes people call it heuristic. We are using heuristic. So after obtaining the early morning urine. You obtain the early morning urine, then you remove the reagent strip. Sorry. You remove the reagent strip and immediately recap. You immediately recap the urine container. After recapping, you're going to insert or to immerse this strip in urine, and you make sure the urine covers the whole pad where the specific gravity pad is. Then after inserting, you put it for a little while, then you remove it immediately. Remove and tap excess. You tap excess of the urine, then you leave it to stand horizontally. You leave it to stand horizontally for 1 minute, and you compare. If this is the bottle which was containing heuristic or reagent strip, after 1 minute of lying horizontally, you come and start comparing, then you read the specific gravity. So this is the reagent strip method, which is being commonly used in hospital. This is being commonly used in hospitals, whereby the heuristic bottle comes with a color standard chart that after reading you can compare the results. So the last method now we are going to talk about is the specific gravity bottle. And this is mostly asked in exams, so you have to master it. So the third method is, excuse me, so this is the weighing method, where we are going to use specific gravity bottle. And the requirements, we shall need weighing scale, shall need the specific gravity bottle. We shall also need distilled water and urine, early morning urine. So after obtaining this, what we do, we first weigh or measure. We first weigh the empty bottle, the empty specific gravity bottle, and record in grams. Let me say, e.g., maybe it was Y grams. Record. And make sure that this bottle is clean and dry. When it is clean, it has to be clean and dry. So after obtaining the weight of the empty specific gravity bottle, you're going to come and now you put the urine in the bottle, put the urine in the specific gravity bottle, then you stopper or cover. You have to cover. After covering, you wipe outside the bottle. In the case of spillage, you remove the spillage because it can contribute to the weight. So you stopper and then you wipe outside of the bottle to remove any spillage. Then after doing that, you're going to weigh, or you're going to obtain the weight or to measure the weight. Here you measure the weight of the specific gravity bottle containing urine and record. You record the weight. Maybe e.g. you can say the weight is 8 grams. I'm just assuming. Then after obtaining this, you pour away the urine, you rinse, then you rinse the bottle several times with distilled water. You rinse the bottle several times with distilled water. After rinsing, then you add distilled water in the bottle and you obtain the weight. You obtain the weight of the bottle with the distilled water. E.g. maybe you have got big grams. So after obtaining the grams of the empty bottle, you obtain the grams of the bottle with urine and obtain the grams of the bottle with the distilled water. When you have these three, the empty, the one with urine, the one with the distilled water, and every time if you put distilled water here, you make sure you stop or you cover the bottle and wipe excess from outside every time you are going to weigh. After this, you are going to obtain specific gravity, which by specific gravity is got by weight of urine over weight of distilled water. And we have seen, according to our illustration, that the specific gravity of urine is going to be, to get the weight of urine, you have to get the weight of the bottle with urine, then you subtract the empty. And to get the weight of distilled water, you get the weight of the bottle with distilled water, then you subtract the one of the empty. And we have seen that the weight of the empty is y. So we are seeing that, can illustrate it this side, that so we are saying that specific gravity is equal to, we're going to get weight of a specific gravity bottle containing urine. We subtract the weight of the empty bottle, subtract the weight of empty bottle, then over weight of bottle with the with the distilled water, minus the weight of the empty bottle, which is going to be the weight of the bottle with urine. We have seen it is 8 grams. So it is going to be 8 grams minus the one of the empty, which is y grams. Then over the weight of the bottle with the distilled water, which is b grams, minus the empty, which is y grams. So at the end, we are getting a minus y over b minus y as the answer. Grams goes with grams. Grams go with grams. So this is the specific gravity, and that is how it is determined. And previously we told you that the reference range is between 1.011 to 1.030. And we said below this is dilute, above this is concentrated urine. This one, dilute urine, means the kidney is failing to reabsorb more water. Concentrated meaning you're dehydrated. Every urine you're producing, the water is being reabsorbed. So those are so we can do it. In this one, we can rule out dehydration. And this one, we can rule out any kidney condition that hampers with the reabsorption of water, like maybe deficiency of antidiuretic hormone and so forth. So thank you so much for learning with us. This is what we are able to discuss with you, whereby we have discussed 3 major methods: urinometer, then specific gravity using reagent strip, and the last one using specific gravity water bottle, which we call weighing technique. Thank you so much for learning with us. May the Lord continue to bless you.